If you've ever taken a first aid class, you know that the best way to control bleeding is to apply pressure directly at the site of injury. And if you haven't taken one of these classes, now you do know. If the bleeding is really bad, you might even need to call 911. When the paramedics arrive, they'll make decisions based on where on the patient's body the bleeding is located. If it's on an arm or a leg, they can apply a tourniquet, which will press against the bleeding blood vessels and keep it controlled while they get the patient to the hospital. The problem comes in when the bleeding isn't on an arm or a leg, and it's somewhere instead like the abdomen. In these cases, the bleeding is so hard to control that it's almost a 50-50 shot if they can even get the patient to the hospital in time. We call these wounds non-compressible due to the squishy nature of these body parts. As a PhD student in the Hargett lab, I'm working to change that outcome by designing a material that can be used to stop bleeding in non-compressible wounds. This material has three components: a foam, a clay, and a gel. The foam we can think of as being similar to packing peanuts. So with these foams, we can squish them into a tiny shape, and then they'll expand out once they're in contact with blood. It takes less than 2 minutes for that expansion to happen. Now, it's pretty cool on its own, but what makes it really interesting for bleeding control is that I can use a syringe to pack a bunch of tiny foams into a wound and then have them expand back out, applying pressure on a wound that was previously non-compressible and turning it into a compressible one. But it's not just enough to apply pressure. I want to speed up the clotting process as well. This is where the gel and the clay come in. The clay is in the form of these tiny particles. They're much too small to see with your eyes, but they can interact with the proteins that are in your blood and help speed up the process that's naturally occurring already in your blood. The gel acts as a sort of adhesive and provides a mesh that can help keep red blood cells together, much like how a clot normally would form. The final thing that I'm looking at is biodegradability. So a lot of times they're similar products, but they need surgery to be removed. This increases risk and means that patients will take longer to heal. All of the materials that I'm using are biodegradable, so a doctor can take them out of a patient's body if they need to, but they don't have to. This will help patients heal faster and get them back on their feet. As I keep working on this material, I'll have both the patients and the medical providers in mind, so that when the paramedics show up to somebody who's bleeding in their abdomen, they'll be able to give them a fighting chance at survival. Thank you.